Well, welcome everyone to the Cyanobacteria Microalgae in Situ determination with the AlgaeTorch webinar. We ask that you keep your microphone on mute for the duration of the presentation and put any questions you have in the chat so that they can be addressed accordingly. There'll be ample time to address questions after Dr. Luce's talk. For any that we don't get to, we'll be sure to follow up directly with you via an email response. So please allow me to introduce Dr. Detlev Luce. Dr. Luce studied biochemistry at the University of Hanover, Germany, and received his PhD from the University of Dusseldorf in 1986. He spent more than 10 years in fundamental research specializing in plant biochemistry. And for the last 22 years, Detlev's focus has been on the knowledge transfer regarding photosynthetic processes in algal pigments. So I am going to let Dr. Luce take over and do his presentation.
Yeah. Thank you very much, Carrie, for this kind introduction. Well, today I want to talk about the AlgaeTorch. The name says it already. AlgaeTorch means that we deal with algae here. And as already described, we are looking for the measurement in situ, which means that we use such an instrument shown here in the first slide in the field. But before I go into the details, I would like to tell you something about phytoplankton, just for those who are not so close related to this. Phytoplankton means that it is small algae cells drifting inside of a water body. And of course, these algae are consist on different types of organisms, so that we have, for example, diatoms, very famous in springtime. We have the blue-green algae or the cyanobacteria, which can cause harmful effects. We have also green algae and, well, quite a lot of different algae. And perhaps, as you know, for example, from the Florida coastal areas, you have the red tides, which are also small organisms belonging to the phytoplankton. So therefore, it might be interesting to determine these algae and get an information about the amount. And this is the second point. I want to talk about algae determination and how to measure it. Then we have the advanced fluorometry, which uses a technique I want to introduce here. We have then the AlgaeTorch, this instrument. I want to explain some of the features and the handling, of course. And with this, I would like to show you some application, how to use it in the field. So this is an example, and at least I will tell you something about the guidelines. And maybe that at the end, we will have some questions, and I would like to find the right answer for you. So here I want to show you some of the typical pictures, microscopic pictures from algae and the blue-green algae. Blue-green algae are not real algae, but they look quite similar. And I show you this because I think it shows you that the extreme shapes and sizes here on the left side, the nanochlorops, very small one. Then a blue-green algae, spirulina, which is also used for food, and the right one here, chlorella, which is basically used also for food but also for biochemistry. All of these organisms, they perform oxygenic photosynthesis. That is why we have so much oxygen in the atmosphere. Comes mostly in the early stage from algae and blue-green algae. But on the other hand, they also synthesize byproducts. Some of them are very good for us because for our health, but some of them pose also threats. Here I want to show you something which I've got from a paper, let's say around about 4 weeks ago, where they've told us something about the harmful effects. And it was here in the city of Austin, where they could find increased risk for harmful algae on a lake or on 2 lakes. And I do not want to tell you all about this article, but what they do is they found that there were algae. And so then they try to investigate and this is a usual way what will happen. They write here, as a precaution, a sample was taken on Lake Austin and sent for testing last week. So, and then results will be posted at Austin, Texas, and so on and so on. This means that is a typical way, traditional way, to take a sample, bring it to the laboratory, and perform the analysis. Okay, that's okay, but if you want to know what is currently in your lake, you need a much speedier investigation. And so this means that it is often asked to have an, let's say, a management action when you see that such a harmful algae could be inside of a lake. And this is what I wanted to bring over to you. These algae disadvantages, they are really disadvantaged because they reduce the water quality. Well, if you think of the accident in Toledo a few years ago, where the drinking water was charged with harmful compounds, I show you here. On this side is one of the compounds, that is a microcystin. It is made as a byproduct of a blue-green algae. And if you have harmful algae blooms, that means that they have a high proliferation of the algae, then you see that the algae use all the nutrients of the water, they consume all nutrients, and then they die. And with this death, they will be digested by microbes, and they consume all the oxygen, which is also necessary for all the other organisms like fish and so on. So we get death zones inside of the water. These toxins, as here, like the microcystin, they are well known that they pose risk, can make diseases, liver diseases, for example, as chronic effects, but they can have also other side effects. Think of the dinoflagellates you find at the coastal of US America, amnesic shellfish poisoning, for example. And if you want to remove them, and sometimes you have to do it when they are in larger portions at the coast, then you have the high costs to remove it. And of course, these costs will also affect, for example, tourism. So what you see, all of these points, they have a big disadvantage from especially when we focus here in US America on cyanobacteria. I just only think on Lake Okeechobee, where they have problems every day, as I think, but also other parts of the coast of Florida. And it also is very important to know that we have effects on pets and livestock. Dogs, for example, are very can be easily effective. They can die within a very short time. You see here my colleague Annika from our sales office. She's measuring at the lake, and she is going out with her dogs all the time along the lakes here, and even in the shallow water, you can find that there sometimes is a big growth of blue-green algae, which can harm pets within, let's say, in a few minutes, or yes, if they bath, for example, they swallow some water, and this can intoxicate the dogs, and they can die. So it may become important to have an information about the amount of algae which is inside of the water. And as I've told you, there are classical ways for sampling and bring to the lab. And what they are doing is they have different ways of determination. For example, determine the wet weight. They dry it in the oven and weigh it again. The other way is the incorporation of radioactive carbon and count what is incorporated. Another classical way, which is still used everywhere in the world because it's rather cheap, is to count the cell numbers in a microscope. And you can imagine that takes a lot of time, of course, and you need skilled people. Another way is a classical way, which is also established in most countries, the determination of chlorophyll. I will tell you why this is the case, but chlorophyll is usually also used in some ISOs where you extract the pigments and determine the content of chlorophyll, which is a mass, which is let's say a proxy for the biomass. And at least last one is a biovolume, that is takes also the cell number and the shape into account and calculate for the amount of biovolume inside of the water. Also microscopic technique, but it is also laborious. So when we look for the classical methods, I have here again the microscopic counting. I do not want to explain in detail. It's just counting. But the other one, which is also established, is HPLC pigment analysis, where HPLC means high pressure liquid chromatography. So that means high pressure. You have a column and a solvent, and with the high pressure, you push the biomolecules through this column and separate it by size and mass. Others call it also a high price liquid chromatography because the apparatus is really expensive. Then we have the spectrophotometry, where you can also extract the pigments from the cells and measure it with a photometer. That is also a classical way where you can determine the chlorophyll content. And last not least, and that is the main point here, we have the in vivo fluorometry, which uses some features of the cell to determine the amount of chlorophyll inside of a living cell. You can see here a picture of the cells. These are here blue-green algae, which I show you. And here, this is the instrument where we have light that is used to excite the photosynthetic apparatus. Inside you have the photosynthetic apparatus, which uses the energy of the sun and converts it into energy. But some of this absorbed light is also emitted as fluorescence. You can see it here. This is only the color of the fluorescence because this is an extract, but it shows the effect quite clearly. When you illuminate chlorophyll with light and you measure the fluorescence, you get a green light. So that says that the light that you get from the fluorescence is far away from the wavelength that you use for the excitation or for the illumination. And that is what we are doing. We use this fluorometer and excite here with the light, the algae, and they emit fluorescence. And this fluorescence is related to the content of chlorophyll A. And why we do this with this AlgaeTorch? Yeah, well, you see it here in on the picture on the right side with my colleague Friederike. She uses this AlgaeTorch. You just have to dip it inside, and this parameter is so easy to access. Yeah, you just to dip it in, start the instrument, and get immediate answer within milliseconds to get the amount of chlorophyll A inside of the water. The second advantage is that you will have here also a high sensitivity. It's, let's say, by a factor 100 more sensitive than the photo measurement. And you have also no sample preparation. You just have to put it inside, no extraction. And it's also in real time calculated so that you will get an answer within the time when you are at site. Another advantage is that makes it also distinct from other instruments available on the market. We use calibration procedure, which is established in our laboratory. We use real algae. I will show you a picture then. And of course, all these can be used also a proxy for other scale bases, for example, to determine biovolume. But this is a little bit more difficult. So what's the value of the AlgaeTorch readings here? This is in a lake in China, where you get an information about the chlorophyll content, which is a measure for the phytoplankton. And it indicates also the water quality. So for example, if you want to produce drinking water from a reservoir, it's quite good to know where are the algae, are the blue-green algae that you will not take in your extraction tubes, water with higher contents of algae. And of course, if cyanobacteria are inside of the water, you can detect them in real time, and they may pose a threat on human health and therefore should be omitted from this water. This is now the principle of, let's say, of all of these instruments. You see here in this picture the illuminating LEDs, and switched on one after another and illuminate the different antenna pigments inside of the algae cells. And then the fluorescence is emitted and measured here in the center, where we have the photo detector, a photodiode, which is used to determine the amount of fluorescence. And for any turbid particles, we also measure the turbidity, which turbidity can also swallow light, which is no longer available for the excitation of the algae pigments. So therefore, it is important to have such a compensation integrated. When we look on the market, so you will find a lot of different fluorometers which are available. Well, they also have some features which are common in fluorometers, but many of them have only relative units. We are not quantitative measurements because they do not have a real calibration inside. So they measure also fluorescence, but it is the result is given, let's say, in number of cells, or if they have, for example, a measurement of CDOM, that is colored dissolved organic matter, then they will have not a compensation for that. We can make it better because we can determine the CDOM already in the blank and have this stored inside of the AlgaeTorch, and it is subtracted from the values that we measure. Some of them use also the measurement of other fluorescent pigments like the phycoerythrin or the phycocyanin, which are prominent pigments in cyanobacteria. But from this, you cannot calculate the amount of biomass because these pigments have a high variability. When they are released from the cells, for example, fluorescence signals are much more enhanced, which means that is really no longer related to the amount of cyanobacteria. So that means that all these measurements are without computation. In contrast to our instrument, where we have the spectral data of algae integrated, but I will show you this in the next slide. And I also have to indicate that we try also to reduce the effects of interference by other effects like turbidity or other compounds which might disturb the measurements. So here I show you a picture where you see the different algae inside. You see that these are here a green algae, that is chlorella, for example. This is a diatom here. We have here a dinoflagellate, and we have here the blue-green algae. And that means they all have different pigment composition. And these different pigment composition helps the algae to be more effective in catching the light. So these pigment systems are light traps, and they convert this light into energy. But to get all of these information, all this fluorescence, which we measure here with the AlgaeTorch, we have to cover the entire wavelengths that are used to excite the algae pigments. And therefore, we need some more than only one light. Simple fluorometer use only blue light and measure red light. We use different lights. Here we have 3 wavelengths for the simple AlgaeTorch and measure the emission, which is always at the same wavelengths as with the other fluorometers, what we get more information from the different algae. So we use the accessory pigments additionally not only the fluorescence, not only the excitation of the chlorophyll A, which gives us much more information. So this allows also to make a quantitative measurement when you have only one wavelength, like the blue LED to excite, you get much less instrument and maybe miss, for example, completely blue-green algae. Calibration is the other thing which I would like to emphasize here. We do this here in our laboratory. You see here in these bottles, in this flask, you see the cultures of blue-green algae, and we have a lot of them, which we use here for calibration. We found that we can use, let's say, 4 algae, different algae from each class, which we have. We have here the green algae, we have the blue-green algae, we have the diatoms, the cryptophytes, and another one, the planktotic, which is also a blue-green, that we use normally for the determination and calibration of our instrument. For the AlgaeTorch, we only use green algae and blue-green algae, but it is sufficient because with the AlgaeTorch, we determine the amount of total chlorophyll, which is all algae with inside of it, and especially the blue-green algae, because with the AlgaeTorch, we want to focus on blue-green algae as a class which poses a high risk to contaminate the water or is a high risk for human health. So here we use blue-green algae and green algae and calibrate this here in our laboratory. So, and this is based on our algae cultures, and we found that these algae that we use represent, let's say, almost all of the algae you find also in the nature. What is about the measurement here? You see that we have the turbidity measurement included beside chlorophyll measurement. We have here the reflection of light, and we use formacine as a standard to calibrate it, so that you can see that we can have also the measurement of formacine turbidity units, but mainly this is used for correction of the chlorophyll measurement, but the additional information is available. The handling is also important. You have keys here below the display. You can just have to touch them and then dip it inside of a water. This is here in close to Kiel, where I tried to measure algae, and you can see that it's very easy to start up. You can explain it within a few minutes how to work with this. So it's maybe also in not skilled hands be a useful instrument, as you can see here in a lake in China, West Lake, close to Hangzhou, where the daughter of my colleague tried to determine algae. And immediately after this takes about 10 seconds, you will get the results here on the display. And you combine it also with the position from GPS. We included this information, for example, in Google Earth. You can see here, when you go around with this AlgaeTorch, determine the cyanobacteria, you get the information about the content of cyanobacteria, chlorophyll A, and total chlorophyll A. And if you want to get more, you get also the turbidity and the timestamp of this and the coordinates, of course. Now, an example which we did a few years ago. This is a reservoir in Brazil, where there's a company producing the drinking water for a very large city. And what you see here, this is in the back here, it is a reservoir where they take the water and filter it and purify it. And we had the chance to accompany them for a tour where we went out with a boat and tried to measure. And important it was that we want to know about the algae content. And here we had a special way of application. We used this AlgaeTorch, which is prominently designed for the measurement of surface water, but here we used it to determine also depths. In the depths, we did a small profiling, and what we could see that there was some content of blue-green algae. Let's have here see in this here in a table where we have the AlgaeTorch at 3 meters, where we find the most blue-green algae. It is, let's say, a small amount, but what you can see at the surface, there is not that much of the blue-green algae. So it was very informative to see here in this graph this maximum at 2 different places. Yeah, that means that when you measure at the surface, you may miss some of these blue-green algae, and so therefore this could be helpful to perform also a depth profile. And with this AlgaeTorch, you can measure up to, let's say, to 10 meters, but we have also a 100-meter version. Luckily, we had the chance to compare this also with other instruments. You see here a more, let's say, sophisticated fluorometer from our company, that is the Algae Lab analyzer, which can do much more than the AlgaeTorch. We have here the measurements from the field, which I showed before, and we have here the classical way to determine spectrophotometrically by extraction of the pigments in acetone and measure the dissolved pigments inside of a photometer. And what you see here, we have the samples as before, and we compared the 3 instruments, and I would say fairly good. We find the results fit to another. You have to imagine that the results are really quite different. We took this directly from the field, while the other samples were transferred to the laboratory. It took a little bit time, and the methods are also very different because extraction may not be complete. So, but therefore I can say that we fairly find a good result, that these results fit together. So therefore, I think one can imagine that this way to perform chlorophyll analysis may replace much more and more the classical way of spectrophotometric attempt. We see this, for example, in China, where they try to convert to fluorometry, which is a, let's say, not only cheaper way to determine, but it is less laborious and does not consume organic solvents, for example. So almost at the end, I would like to tell you something about thresholds, because we are always asked for thresholds and levels. What are the indications? And if you look here, for example, for cyanobacteria, then you can see there are thresholds or levels which are, let's say, not really thresholds, but more guidelines, because it's not that easy. The World Health Organization published a paper many years ago where they had here these values, and you can see here that is expressed in microgram chlorophyll A per liter. And you can see that small amounts here for drinking water gives you an alert. What it makes difficult is that in the classical way, they also had on this tree the number of cells. A number of cells and chlorophyll A, it is not that very well good related. The reason for that is quite clear. Sometimes you have a bigger cells, sometimes we have smaller cells with different chlorophyll contents, or what I've showed you before. You have these filaments, which are not that easy to count, or if you have, for example, colonies, then it's also very difficult to determine the exact amount of cell numbers. So therefore, you see, that is just an idea. I would say these are some numbers which can help you to have an idea what has to be made when you find levels. And many of the organizations use such numbers to let's say, to stop tourism, for example, or set warning notes not to enter for bathing. So therefore, these numbers might be helpful, but the responsibility is depend on the different organizations. As you know, you have enough in US America, which provide you with such warning notes from time to time. So in conclusion, I would like to tell you what you get from the AlgaeTorch, and you see here on the right side, people using this AlgaeTorch for the improvement of the water quality by sonic sounds. They use the measurements of total chlorophyll here in real time with the AlgaeTorch. They get the information of the cyanobacteria, which is important when you try to restaurate the water of a lake, for example. You have the turbidity measurement, which is used also to correlate the real chlorophyll content with the measurements. You have the GPS integrated to give you the position. You have the integrated display where you can measure immediately the results. We have the real algae calibration from our laboratory. And we have all in one, we have also storage inside of it, or a memory inside of it, where you have around about 2,000 data sets with the internal data logger. And of course, it's a robust housing where you can use it. It's in the field. And for the ladies, it is lightweighted. It weighs only 1.3 kilograms. So therefore, it is practical for work in the field. Yeah, and of course, it has an internal battery. I forgot it. Yeah. So thank you very much for your attention, and hopefully you have some questions for me, which I try to answer.
Okay, well, thank you very much, Detlev. That was terrific.
Yeah.
And we do have some questions here. We'll start off here. Is there any reason to suspect differences in fluorescence from cultures versus natural phytoplankton communities found in natural waters?
Yeah. Indeed, as I've told you in the beginning, let's say from the history, when in the history we started up with a library or a collection of many different algae. We cultured them in our laboratory and used them to find out if this works. Yeah, so that means when we started up, we had a lot of different algae. And then we used this also to compare this with algae in the field. And at the end, as I showed you for the calibration procedure, we found that four algae species are sufficient to perform this calibration. Not in all times, but in most times. So these four algae are representatives for all the classes that we usually find. If you see that there are differences, we can adapt it. Usually it's not necessary for the, let's say, for the AlgaeTorch, because we only measure total chlorophyll in cyanobacteria. For the cyanobacteria, it fits quite well, but we see that sometimes we had outliers, and with the other instrument, we could also introduce in other instruments that we offer a special algae class different from that what we have here. So in general, we can say this fit is rather good, but we have we had some exemptions where we have to adapt it. For this, let's say, simple type of measurement, I think it's sufficient to have the blue-green algae separated from the other algae, and I can say the total chlorophyll is very well met with this type of measurement, and therefore we can say the algae in the nature are very close to that algae that we keep in the algae in the culture. We are very close to that we find in the nature. there is some reason why we think, or we have to reconsider this. For example, when we have the death of algae, then we find also a shift in these spectral features. But it is a very extreme situation. And then you can see it also by naked eyes. So therefore, when you see something like this, like a bloom, a dying bloom, you do not need a fluorometer. Yeah? A fluorometer is when you want to see the dynamics or the development of the algae. When you have a massive bloom, you can see it by visual inspection with your naked eyes. So therefore, I think the AlgaeTorch is suitable for both measurements in the nature, and we have a lot of these instruments already sold for any purposes in freshwater, in lake water. And as you can see here also from the picture of the restoration of the lake, it is used really in natural waters with natural algae.
All right, terrific. Next question, can one submerge the AlgaeTorch and get a profile from top to bottom in the water body?
Yeah, well, as I try to explain, the AlgaeTorch is not a real instrument for profiling. So when I try to make a profile, I use a rope together with the AlgaeTorch. The AlgaeTorch has not a depth rating. The AlgaeTorch this type is for maximum depth because of the pressure resistance only to 10 meters. And I connected it to rope and let it down to a certain depth and measure then, for example, for 2 or 3 times the fluorometric signals. And I get information when this measurement is done, because there is a vibrational signal which I can feel on the rope. And then I know the measurement is performed. I can use another measure and another measure, have to say 3 values. And then I can pull out the fluorometer again and afterwards read the fluorometric results. So therefore it is suitable to perform this, but it's not that easy, because one measurement takes, let's say, around about 10 seconds. And that means you have to wait until you are in a certain depth. We have another AlgaeTorch which is designed for 100 meters with a depth rating, for example, and then you can measure also up to 100 meters using also these different steps. But in general, I would say this is a measurement more for the surface. We have another instrument. You can get the information from Tim about this, the fluoroprobe, which is really a submersible instrument, which is designed for real profiling. But here you can see it when you need only sometimes a profile, you can do this with the AlgaeTorch.
Next question, knowing algae abundance is useful, but it doesn't actually tell us if there is toxicity. Is there a reliable relationship between what the AlgaeTorch measures and the actual risk of toxicity?
Yeah, that is a good question. Indeed, that is difficult to answer. Well, it is said, and you can find it in the scientific papers, that more than 50% of the cyanobacteria can produce these biotoxins, but not all of them do that. So therefore, we can conclude that there is a certain probability that you can find the biotoxins. The advantage of this instrument is that you can get the information about the presence of the cyanobacteria in a very early stage. The measurement or the determination of the biotoxins takes a longer time, and you have to bring these samples really to the laboratory and to perform a sophisticated analysis. So usually they made also this measurement of separation on columns, and afterwards mass spectroscopy to identify the biotoxin, and this takes a long time. So therefore, the advantage lies inside of the rapid detection of the cyanobacteria. But in reality, you can say that there might be a high probability that there can be some biotoxin inside. The fluorometric device does not show anything of the biotoxin itself. It's not, at the moment, it's not possible to have a method to determine the biotoxins in real time and in situ. So therefore, the AlgaeTorch is a helpful tool to indicate and, for example, react with a warning note that there might be some biotoxin inside, but the answer comes later from the lab.
Okay, so the question was, is phytophyton compensated for in any of these measurements?
Field Cyanobacteria?
Phytophyton.
Okay. Phytophyton.
Yes.
Phytophyton. Yeah. Okay. That's I understand now. Phytophyton usually is not inside, let's say the spectrophotometric pattern of phytophyton are different from those that we measure, because you have to imagine that we do not extract it. We measure the chlorophyll A fluorescence, and if you have a phytophyton inside of the, let's say, of the algatens, because it is decaying, yeah, then you can not see this with a fluorometer. So therefore, for the ISO method, it may be useful to have this correction for the phytophyton, and they subtract it, for example, but from in situ measurement, we are in a different range. So therefore, we have no overlap from the phytophyton signals to that chlorophyll A, what we measure. Some scientists believe, that's not my opinion, but some scientists believe that in reality, you will not find the phytophyton at all. So that means that it is an artifact of laboratory, but I'm not a specialist because I do not use this laboratory method. I prefer to do fluorometric approach. And I think this is now the answer, of course. I hope so. I understood it right.
Okay.
Yeah, okay.
All right, well, if there's no other questions, Carrie, we can finish it up.
Okay. Well, first of all, Detlef, as always, thank you for your presentation, and thank you to everyone for your questions. If you have any additional questions related to this material, please feel free to reply to the email that you received from me, and we'll answer your questions directly. But everyone have a great day, and thank you for your time today.
Thank you very much for attention. Thank you and goodbye.
Thank you for attending this webinar. To learn more about the BBE AlgaeTorch, visit ppsystems.com.